Up to now, we've looked at a number of types. Can you remember them off the top of your head? We looked at string, number, boolean, object, undefined, and function as its own type. And there are a couple of others that we haven't talked about yet. We'll talk about null later. And then there's symbol, which is new in the latest version of JavaScript. Probably won't talk about that in this course, but what I wanted to point out, though, when we were using string in particular, but this is true of the other of some of the other types that we worked with, it seems to have some methods that are available to it to do some interesting things. So, for example, whenever we looked at regular expressions, and let me just create a new file here called natives.js. Whenever we looked at the regular expression lesson, we did something like value, which is a string set to this literal string. This is XYZ attest. And we did value.replace. Well, how is it that this value has this dot replace method? We really never addressed that. How is it something like a string can have a method? After all, we said that methods are really just functions that are defined inside of an object. So that would make a string an object, right? Or no? But a string's a string. How can that be? Well, actually, both of those are true statements. The fact is that the types we've been looking at so far, like especially string and boolean and number, are known as primitive types. These primitive types then have corresponding built-ins or natives that are functions that return objects with a bunch of cool methods that are added to them by JavaScript. So behind the scenes, JavaScript does something interesting. The JavaScript compiler will coerce your primitive, in this case, primitive string, into an object that's returned from a native string function with all kinds of cool stringy type functionality included. So actually, although we haven't demonstrated this yet, you could create a string using the actual string function to do something like this. And let me comment this stuff out here. And so notice what we did here. Let string equal new. Then here's our function, that built-in function string. Notice that has a capital S. We'll talk about that in a moment. All right. And then if we were to save this, and then let's go ahead and get down here and type in node natives. It works, well, kind of works almost exactly like a normal string. We'll get to that in just a moment. So before I address that specifically, I'm going to work with strings in this particular video and with the string, capital S string function, the built-in, the native string. But what I'm about to say about strings is true whether we're talking about numbers or booleans or other primitives that have an equivalent native associated with it. All right, so I want you to notice a couple of things and we'll work through this. First of all, this starts out just like any other variable that we're assigning to a string, except we use this new keyword. And I'm going to explain what the new keyword means in the very next lesson when we talk about constructors. But basically, this is what creates a constructor call to this function. And then here we are calling a string function, capital or uppercase S in string. But isn't that bad form? Didn't you say, Bob, that we should create our methods with camel casing, and so string should start with a lowercase s? Actually, this is a special situation. It's still a convention indicating that this is a function that should be called using a constructor call. Again, more about that in the very next lesson, so you'll get a part 2 to this. But just keep that in the back of your mind. We'll come back to it. All right. So whenever we run this, as you can see here, when we ran node natives, we didn't get an actual literal string output. Instead, we got basically an object that has a string property and a value set to howdy. We actually need to call a method on this native that's returned from the string function to convert it into a primitive string for the proper display inside of a console.log. So we'll need to do something like let me just comment this out, and we'll go to string, like so. And now, there we go. We grab, we convert that native, that object returned from our native string function back into a primitive string and then display it on screen. Okay. So, and while we're looking at things here, just out of curiosity, let's go console.log and then go type of my string. What would you expect to see here? Well, it is a type of object. All right. So again, what's going on here is that these built-in native types provide extra functionality like this toString method, like this replace method, and others that we'll look at in other lessons. And they provide this extra functionality to their corresponding primitive types. And so just real quick, here's a list of those built-ins, those natives. All right, so it includes kind of corresponding to the primitive string, lowercase s and string, number, boolean. There's also an object, a function, and a symbol. And then there are built-in natives that do not have primitive versions. The primitive version, as you know, of array is object, and the same with regular expressions here, regex. But it does provide this native built-in with extra functionality for our arrays. So the same kind of thing happens. It's just not with directly back to a primitive. It's to an object, but it still works with anytime we're working with arrays. And then there are some other built-in natives that provide foundational data types, I guess you can say, for important features, but are essentially just objects whose methods implement a lot of logic for their features. So things like the date function and the error function. We'll look at these a little bit later. But in this lesson, I want to focus solely on the relationship between primitives and built-ins. So whenever we do something like this, and let me just copy and paste some more code in here. So here we're creating a literal string, and then on this literal string, I'm going to call this method toLowerCase. Behind the scenes, what's happening is that JavaScript's compiler is coercing, it's wrapping, it's boxing that primitive string, my primitive, into a built-in native equivalent in order to provide that rich set of methods that transform the string, in this case to all lowercase letters instead of all uppercase. So if JavaScript is coercing, wrapping, boxing our primitive into this built-in native equivalent, then what happens whenever we need to get a value back out of it? Well, the JavaScript compiler will do the opposite. It will unbox that object back into a primitive without you having to do anything special. It manages it all on its own. So in this case, let's just kind of see what happens here. Just out of curiosity, let's get the type of here, and we'll put the type of there. All right. And we'll see that when we run this. And let me make sure there's nothing else here. Let me comment all this stuff out too at the very top of that file. All right. So now let me save that. And we can see that it treats this literal string as a string here in line 31. Then in line 32, it does that unboxing thing that we talked about to take string, make it into an object so that we can call the toLowerCase method on it. And then what do we get back? Well, at the point when we attempt to find out what the type of my primitive is, it already has, for our purposes, essentially unboxed it back into just a primitive string. All right. So it's recommended that you stick with using the primitive and you allow JavaScript to do its magic. The compilers can do this sort of thing without breaking a sweat, so don't worry about all this boxing and unboxing and its impact on performance. But let's suppose that, just for the sake of argument, that you wanted to start out with a built-in native and you want to explicitly convert that built-in native version of a string into a primitive string, how would you go about doing that? Well, here, let's take a quick example. And let's go ahead and move away from strings and just to numbers, but the same idea will apply no matter what. So I'm going to comment all that out. Let's go let my number equals new number. Notice capital N or uppercase N in number. And then in the constructor argument, we'll pass in the actual value that we want to set that number to. All right. So at this point, let's do a console.log. And let's find out what the type of number my number is. Have any guesses on what it will be? Let's go ahead and stop right there and let's make sure we understand it's of type object at this point. Now I want to take it out of that built-in native and I want to grab just the value of my number out and put it into a primitive. So here we go. Let my primitive, I'll just reuse that variable name here, equals my number dot, and then to grab the value out, regardless of whether we're working with string, number, Boolean, whatever the case might be, we'll use this method on this object called value of. So the value of method, and now we should do a console.log, my primitive. Actually, we know what the value will be. What's more interesting is the type of. So now let's run that. And so here in line number 36, we're going to get, it's an object, but we use value of to retrieve the actual value of our built-in native object into a regular number. And we print that out in line number 38. Okay. So to recap, the point of this lesson is to explain what these functions are that have the same name as our primitive types, but with an uppercase letter. They are built-in native functions that are intended to be constructor called. We'll learn about that in the next lesson. And the JavaScript compiler uses these functions to return an object that supports lots of rich features to each primitive data type, and we'll see those in upcoming lessons. But the JavaScript compiler will box and unbox your primitive types into these built-in native equivalents as needed, and we'll do so without any help from you, and we'll do it all behind the scenes. And you can explicitly create instances of these objects and then use the value of method like we saw here just a moment ago to convert them into their primitive equivalents, but it's not really necessary. So, you know, what's this new keyword all about? And what's this uppercase letter in this function name all about? Well, I'm going to explain that in the very next lesson. We'll see you there. Thanks.